Hello, ma'am.
Good evening, sir.
Yes, ma'am.
Good evening, sir.
Good evening, Ajay. Ma'am, make me a host, ma'am.
Yes, sir, you can continue, sir.
Ma'am, you have made Dhanalakshmi a host.
Dhanalakshmi, will you please make me a host or make sir as a host?
Yes, ma'am.
Yes, sir, you can continue, sir.
Yes, ma'am. Okay, today we are going to finish with this chapter, electrochemistry, and then we'll start with a new chapter on Friday. Okay, a few more questions, another 15, 20 questions. I think I've typed 15 questions. Let's see and work. The question for today is, first one for today. The 0.1 molar copper sulfate solution in calculate the electrode potential of copper. Calculate the electrode potential of copper. They have given you E naught of copper to be 0.34 volt. E naught of copper. Now they're asking you to calculate the electrode potential. Electrode potential is given by the formula E is equal to E naught plus of 2.303 RT by NF log of concentration. This is the formula. This is called as what equation? This is called as Nernst equation to calculate the single electrode potential. This is called as Nernst equation to calculate the single electrode potential. 2.303 and R value is 8.314. 25 degrees Celsius, it means it is 298 Kelvin. And Faraday, we know that is 96,500. So if this value we take and simplify, you will get 0.0591. So therefore, at 25 degrees Celsius, the Nernst equation can be written as E is equal to E naught plus 0.0591 divided by N log of C, log of concentration of the solution, metal ions. Now, can I write this equation otherwise like this? E is equal to E naught minus 0.0591 divided by N log of 1 by C. Can I write? Is this both same?
Yes,
Both the
sir.
equations are same or not? Yes. So any of these equations you can use to calculate the electrode potential. Now what is given? They've given you the concentration to be 0.1 and they've given you the standard electrode potential to be 0.34. Therefore, E will be equal to 0.34 plus of 0.0591 divided by what is N? You can clearly see here, it is Cu2 plus and Cu. Copper 2 plus and Cu. That means here the charge is +2 and here the charge is 0. It means 2 electrons is gained. So N is valency, N copper for valence of copper is 2. Into log of concentration, they've given us 0.1 molar. They've given us 0.1 molar. Now, can I write this equation to be 0.34 plus of, if you divide this, you will get 0.0296 or something. Half of it, 0.296. Log 0.1, can I write it as log to the base 10 of 10 to the power minus 1. Can I write? Can we write 0.1 as what? 0.1 can be written as 10 to the power minus 1. Yes or no?
Yes, sir.
Yes, sir.
So what is this? Log a to the power b can be written as what? Can I write it as b log a?
Yes, sir.
So what happens? It is 0.34 plus of 0.0296 minus 1 log to the base 10 of 10. Now what is log 10 value? Log 10 is 1. So that means it will be 0.34. This is 1. Log 10 is 1. So if you multiply this by minus 1, you will get what? Minus 0.0296. So log 10 is 1. 1 into minus 1 is minus 1. Minus 1 into 0.0296 is minus 0.2096. You will get the answer around 0.31 volt. Approximately, you will get around 0.31 volts. Did you follow? This nasty question is clear. It is a regular 12th standard question also. You should know this formula to work out the problem. This is to calculate the single electrode potential. It is not to calculate the electrochemicals, EMF of the cell. It is to calculate only the single electrode potential. Now coming to the next question. EMF of the cell is chromium Cr3 plus 0.1 molar, Fe2 plus 0.1 molar to Fe. Given they've given you the electrode potential of chromium, standard electrode potential of chromium, as well as standard electrode potential of iron they've given. Now the question is, which of the electrode is undergoing oxidation and which is undergoing reduction? Clearly, we know that as per the cell representation, which is on the left-hand side, will be called as what? Anode. So this will be called as anode. Chromium will be called as anode, and iron will be called as cathode. Based on the electrode potential also, we can remember, larger the value, I told you it is cathode. So iron, you can see the potential is minus 0.45. For chromium, it is minus 0.75. That means this is larger. So therefore, iron will act as cathode and chromium will act as anode. If that's the case, if I write the half cell reactions at anode. At anode, what's the half cell reaction? Chromium loses 3 electrons to get chromium 3 plus. Can you observe that chromium, here the charge on chromium is 0, here it is plus 3. That means chromium charge from 0 plus 3 loses how many electrons? 3 electrons. At cathode, what's the reaction? At cathode, iron from Fe2 plus, it gains electrons. It gains how many electrons? 2 electrons from Fe2 plus 2 Fe and gets reduced to iron. So this is the reaction. This is the half cell reaction. Now just observe this reaction and tell me whether the electrons are balanced. Are the electrons balanced?
No, sir.
No. In order to balance the electrons, what we do is we multiply this equation by 2 completely, and we multiply this equation by 3. When I multiply this by 2, what happens? I get 6 electrons. Here also 2 into 3 is 6 electrons. So what will I get? On overall reaction will be what? 2 chromium plus 3 Fe2 plus 3 Fe. You followed with this overall equation? Yes or no?
Yes,
Yes,
sir.
sir.
Now what will be the EMF of the cell? E cell is equal to E cathode minus E anode. What is cathode here? Iron is cathode, that is minus 0.45 minus of minus 0.75. Anode is this. So what happens? The answer will be around plus 0.30 volt. The answer will be around what? Plus 0.30 volt. Did you follow this? Students, you followed?
Yes, sir.
This is E naught of cell. This is E naught of cell. This is E naught of cell. Now they're asking you to calculate the EMF. So to calculate the EMF, E cell is equal to E naught minus of, since it's not mentioned, the temperature is not mentioned, we will consider it to be at 25 degrees Celsius, 0.0591 divided by n log of product minus reactant. Concentration of the product minus concentration of the reactant. What is the product and what is the reactant? What is the product and what is the reactant here in this case? Now I have taken minus. If it is plus, it will be reactant by product. It will be reactant by product. Now what is that E naught we calculated? E naught we calculated to be what? 0.30 minus of 0.0591. What is N value? Can anyone tell me what is N value? What is N value? N stands for number of electrons, or it stands for valency. Now there's no point in talking about valency here, because chromium here it is 3 electrons and iron it's 2 electrons. Therefore, what is N here? N is the total number of electrons involved in transfer. Now the total number of electrons involved is how much? 3 into 2 is 6. Here is also 2 into 3 is how much? 6. Involved in the loss and gain is what? 6. Therefore, N is 6. Did you follow why I'm writing N value to be 6?
Yes, sir.
Yeah. Now log of, what is the product here? The product is Cr3 plus and the reactant is Fe2 plus. Now Cr3 plus ion concentration, I write to the power 2 because the coefficient is 2. Therefore, we have to write to the power 2. And also reactant here is Fe2 plus. Now Fe2 plus, the coefficient is 3. Therefore, I have to multiply it by thrice. So what will I get? I'll get 0.30 minus of 0.0591 by 6 log of, what is the concentration for chromium? It is 0.1 the whole square divided by iron concentration is 0.01 the whole cube. So on simplification, it's mathematics. On simplification, we will get the value 0.30 minus of 0.24 by 6. So on simplification of all this, you get 0.24 by 6. So on that value, if you divide further on simplification, you will get the value to be 0.26 volts. It's mathematics, so I'm not working on the screen. You can do the mathematics part of it. Did you understand this problem? Did you follow this problem? Now tell me why you get N to be 6. Why do we get N to be 6? Hello? Hello? Ajay? Ajay Dhanlakshmi, can you hear me?
Yes, sir.
Did you understand why N is 6?
So because
sir.
the total number of electrons,
Yeah, total number of electrons
transferred
involved.
is 6, sir.
Yeah. Now, in the previous problem, we learned N to be 2 because there is only one electrode we are talking about. What is that electrode we're talking about? Only copper solution and copper electrode here. Since we're talking about only one electrode, we're talking about the valency of copper to be 2. Therefore, N becomes 2 here. But it is this problem, what we worked is a cell. Cell is a combination of 2 electrodes. When we combine 2 electrodes, then the number of electrons, the net number of electrons involved, you have to write. So that will be 6 here. Next question. Write a reaction and calculate the potential of the electrode. Chlorine aqueous 0.05 molar to chlorine. It's in gaseous state, 1 atmospheric pressure, platinum. Given the electrode potential of chlorine is 1.36 volt. Now, what is that they've given? What is that they've given? They've given the question. Oh, where's that? 1 minute. Yeah. What's that they've given? They've given the electrode potential of chlorine to be 1.36 volt. Now, they're asking you to write the reaction. When I said write the reaction, here the charge on chlorine is -1. Here the charge on chlorine is 0. That means chlorine is undergoing reduction. Now, in order to understand this, so there is no chloride ion existing like this free. Therefore, we are supposed to write the reduction equation as chlorine molecule, half a chlorine molecule. This half a chlorine molecule will accept an electron and here the charge is what? -1. This is the reduction equation. All right. Now, aqueous. And the n value, number of electrons involved is 1. Therefore, we write n is equal to 1. They're asking you to calculate the potential. In order to calculate the potential, we know that it's a Nernst equation only we're supposed to do. E is equal to E naught of what? Chlorine electrode. They've given you here. Minus of 0 temperature they have not mentioned, the 0.0591 divided by n log to the base 10 of the concentration of chloride ion divided by concentration of the chlorine gas to the power half. See here, if you remember, we learned the reaction here, product by reactant, concentration of product by reactant. Product is chloride here, reactant is chlorine. And chloride, we have only one chloride ion. And chlorine, we have half a mole. So the coefficient is half. Therefore, we have to raise it to the power half. Now, what's the potential of chlorine they've given? They've given you the potential of chlorine to be 1.36 minus of 0.0591 divided by 1. Valency of chlorine is 1 to the log to the base 10 of. What are the concentration of chlorine? They've given the concentration of chloride ion to be 0.05. And what is the concentration of chlorine? Chlorine is half. 1 is the coefficient, half. So it will be divided by 1 to the power half. So on simplification, the answer what we will get is 1.36 minus of, we will get, not minus, we will get plus. When you simplify, you will get plus 0.1596. This part, if you simplify, you'll get plus 0.1596. Totally, the potential will be 1.52 volts. This is the electrode potential or EMF of the cell. Now, I want you to do the mathematics part of it. This you calculate, this value if you calculate, you will get minus 1.1596. Minus into this minus becomes plus. That is what I've written plus sign here. So you can work it out and see the problem. Clear? Students, are you there with me? Yeah.
Yes.
Yeah, the next problem is a little different. Let's see. We'll try to understand this. Calculate the potential of the electrode. pH they've given to be 4.5, and they've given hydrogen gas 1 atmosphere, pressure of hydrogen gas to be 1 atmosphere, and given you platinum. This is what they've represented. It is nothing but hydrogen electrode, if you remember. They have given pH to be 4.5. pH means concentration of hydrogen ion. What is the electrode potential of hydrogen? What is the electrode potential of hydrogen? What is the electrode potential of hydrogen?
The 0.
0 volts. We assume it to be 0. It is not 0. Okay, standard hydrogen electrode. They are asking you to calculate the electrode potential of hydrogen. See, this is a standard hydrogen electrode potential. That is 0. This is standard. E not indicates standard. They're asking you to calculate the potential of the hydrogen electrode. Now, you should know the reaction. What's the reaction taking place at hydrogen? Similar to the reaction of chlorine, what we learned. Hydrogen H plus will accept an electron and get reduced to hydrogen gas, half a mole of hydrogen gas. Okay, this is a gas. It's a reduction. Here is +1. Here the charge on hydrogen is 0. Since we have only one hydrogen atom, it accepts 1 electron to form half a mole of hydrogen. And in this equation, the number of electrons involved is 1. What will be the electrode potential of hydrogen now? The electrode potential of hydrogen will be equal to E naught of hydrogen. E naught of hydrogen, we know that it is 0, but still we will write E naught of hydrogen minus 0.0591 divided by N. N is 1 for hydrogen plus into log of. Now, what is the reactant and what's the product? Reactant is what? H plus, and the product is what? H2. So product by reactant, so it will be H2 concentration to the power half divided by concentration of H plus. Concentration of H plus. Now on simplification, we can write this is 0 and this will be minus of 0.0591 because n is 1. N is 1 log of 1/2 because concentration of hydrogen is 1/2 divided by what's the concentration of hydrogen ion? The concentration of hydrogen ion we don't know. The concentration of hydrogen ion we don't know. In order to find the concentration of hydrogen ion, what they've given is pH is 4.5. So pH is defined as negative logarithm to the base 10 of H plus ion concentration. pH is given by the formula negative logarithm to the base 10 of H plus ion concentration. That will be written as logarithm to the base 10 of 1 by H plus ion concentration. So 1 by H plus, the negative sign will get cancelled. So therefore, we can write, see, this is 1 by H plus ion. This is 1 by H plus ion. This value, what we're getting is 1 by H plus ion. So therefore, we can write the equation to be minus 0.0591 into pH. See, this is nothing but log of what? 1 by H. Log of 1 by H is nothing but pH. What's the value for pH they've given? Minus 0.0591 into what? 4.5. So on simplification, the answer what we will get is minus 2.664, not 2 point, minus 0.2664 volts. Did you follow this problem, students? It's a tricky problem. Did you understand this?
Yes, sir. Understood, sir.
Yeah. Others, then Lakshmi and others followed?
Yes, sir. Followed.
Yes.
See, this problem, it's a different problem, different type of problem. You should go through this video 2-3 times so that you can understand the problem better. Now they've given you the next problem is the conductivity of pure water in a conductivity cell with electrodes of cross-sectional area of 4 centimeters square, placed at a distance 2 centimeters apart, is 8 into 10 to the power minus 7, 10 to the power minus 7 Siemens centimeter inverse or Siemens per centimeter. Calculate the resistance of water. And second, asking the current that would flow through the cell and applied potential of 1 volt. Now, how do you calculate cell constant? Yesterday we learned cell constant is represented by the formula L by A. L is 2. They have given the distance to be 2 centimeter and the area is 4 centimeters square. So therefore, it will be half centimeter inverse. So cell constant is half centimeter inverse. Now, the first part of the question, they're asking you to calculate the resistance. Now, I know that specific conductance is 1 by R into L by A. 1 by R, inverse of the resistance. So R we can write, this K is specific conductance, or we can write R is equal to 1 by specific conductance into L by A. They've given you the specific conductance, they've given you as 8 into 10 to the power minus 7 Siemens per centimeter. So that will be equal to 1 by 8 into 10 to the power minus 7 into L by A is half. L by A is half. When you simplify this, you will get 6.25 into 10 to the power 5 ohms. This is the first part. This is the resistance of water. Water is also a very weak electrolyte, remember. So the resistance is more, that is 6.25 10 to the power 5 ohms. Now the second part of the question is the current that would flow through the cell under the applied voltage of 1 volt. Now current they're asking. Now from Ohm's law, we can write V by I is equal to R. V by I is equal to R. Or what will be I? I will be V by R. What's the voltage they've given? 1 volt they've given. And resistance we found out here, it is 6.25 into 10 to the power 5. So on simplification, we will get 1.6 into 10 to the power minus 6 amperes. The current is in amperes. Did you follow this problem?
Yes, sir.
Yes, sir.
Yes. The next question is, the next question is, Predict whether the following reaction can occur under standard conditions or not. Predict whether the following reaction can occur under standard conditions or not. How do you predict whether the reaction occurs at standard conditions or not? Now, before we understand this, this is the cells, iron, tin and bromine. Tin undergoes oxidation, +2 to +4 oxidation. Bromine from 0 to minus, this bromide ion, -1. So bromine undergoes reduction. Now tell me, as per this, tin has +1.15 volt and bromine has 1.6 volt, which will be anode and which will be cathode. Tin is undergoing oxidation. Tin will be anode and bromine will be cathode. Now you can calculate the EMF of the cell. What is E cell? E naught of cell is equal to E naught of cathode minus E naught of anode. Cathode is bromine, so it's 1.06 minus of plus 0.15. So on simplification, you will get 91 volt. So E cell is 0.91 volt. Now what is this? They're asking, predict whether the following reaction can occur under standard condition or not. I am telling you the reaction will not occur under standard condition. Why? Why the reaction will not occur under standard condition? No, reaction can occur. Sorry, reaction can occur. Reaction can occur. Why? Reaction can occur at standard conditions. Why? What is the relation between free energy change and electrode potential? Delta G naught is equal to minus NF E naught of cell. Now E naught of cell is positive here. When E naught of cell is positive, E naught of cell is positive, what happens to delta G? Delta G becomes what? Negative. When delta G is negative, what's the reaction called as? Spontaneous reaction. That means reaction can take place without the help of any agency. See, E naught is positive, delta G naught becomes what? Negative. Therefore, the reaction can proceed. That's why we've written, since E naught is positive, reaction can occur under standard conditions because delta G naught becomes what? Or delta G naught becomes negative. Therefore, the reaction is what? Spontaneous. Followed?
Yes, sir.
All right. The next question. Where's that question gone? Yeah. Calculate the equilibrium constant for the reaction at 298 Kelvin. Zinc, the charge here is 0. Here the charge is +2. Zinc is undergoing oxidation. Copper from +2 to 0. Copper is undergoing reduction. Larger the value, reduction. Lesser the value, oxidation. I'm repeatedly using this statement. Please remember. They're asking you to calculate the equilibrium constant. So remember, equilibrium constant is related as Kc is equal to N E naught cell divided by 0.0591. So this is the formula. N E naught cell divided by 0.0591. Now what is E naught cell? E naught of cell is E naught of cathode minus E naught of anode. What is cathode here? Cathode is copper, 0.34 minus of minus 0.76. It is 1.1 volt. It is 1.1 volt. And N is 2 here. Why N is 2? Because +2 to 0. 0 to +2. 2 electrons involved. So therefore, it will be 2 into 1.1 divided by 0.0591. On simplification, we will get, oh, I made a mistake. It is log Kc. Log Kc. So log Kc will be equal to 37.29. Log Kc will be for Kc. Kc will be anti-log of 37.29. So anti-log of 37.29 is 1.95 into 10 to the power 37. You please find out how tricks of finding the anti-log from the physics teacher. You can take their help because they will be using log often. All right, so you please take it or learn it from the physics teachers. Request them to teach you. Or if you know, it's well and good. Did you understand this relation? Equilibrium constant, how do you calculate this formula? Can you remember?
Yes, sir.
Yes. And Lakshmi and Ritika, others?
Yes, sir.
Yeah. Okay. The next question. Calculate the EMF of cell EMF and delta G for the reaction at 298 Kelvin. They've given you zinc concentrations, they've given you cadmium, they've given you concentration, and E naught of zinc, they've given you E naught of cadmium, they've given you as minus 0.40, not minus 0, it is minus 0.403. Okay, they're asking you to calculate the EMF of the cell and they're asking you to calculate delta G. Now, how do we calculate the EMF of the cell? Before we calculate the EMF of the cell, we will calculate E naught of cell. What is E naught of cell? E naught of cell is E naught of cathode minus E naught of anode. What is cathode here? Which is larger here? Cadmium is undergoing reduction. This is cathode and this is anode. So E naught of cadmium minus E naught of zinc. That is minus 0.403 minus 0.76. So it will be minus 0.403 plus 0.76. So that will be equal to 0.36 volts. 0.36 volt. E cell is 0.36. Now tell me, how do I calculate the EMF? EMF of the cell or E cell is equal to E naught of cell minus 0.0591 divided by N log of product concentration by reactant concentration. So E naught of cell we found out to be 0.36 minus 0.0591 divided by, what is N here in this equation? 2 electrons are lost at zinc and 2 electrons are gained at cadmium. Therefore, N value is what? 2. Log of, what's the reactant here? Reactant concentration. Zinc is the reactant. So it will be 0.004. It's not 3 zeros. It's 3 zeros only. 3 zeros only. 004. And concentration of cadmium is 0.2. It is not 0.24. It is 0.2 molar. So on simplification, we will get the value to be 0.44. This is E cell. Now, once we have calculated E cell, can we calculate E naught, delta G naught? What is it? They're asking free energy, G naught. Now, what is G naught? G naught or delta G naught is equal to minus NFE, not delta G naught, E cell. So minus N, minus 2, 96,500 into 0.44. So on simplification, we will get this value to be minus 84,920 coulombs. 84,920 coulomb volt, or it will be in terms of what? Joules, minus 84,920 joules. Followed?
Yes, sir.
Yeah. This is a different type of question. I don't know whether we work, I don't remember working. The specific conductance of saturated solution of silver chloride. Specific conductance of saturated solution of silver chloride is found to be 1.86 into 10 to the power minus 6 ohm inverse centimeter inverse. And that of water is 6 into 10 to the power minus 8 ohm inverse centimeter inverse. The solubility of AgCl is, they have given lambda naught of AgCl is 137.2 per ohm centimeter square per equivalence. Now they are asking you to calculate solubility. In order to calculate solubility, now we can write, they have given you the conductance of silver chloride as well as the conductance of water. Now, conductance of silver chloride is equal to conductance of silver chloride solution minus conductance of water. That will be equal to 1.86. See, this is for solution. If in solution we have water, if you remove the conductivity of water, we get the conductivity of pure silver chloride. That is what they've done. 1.86 into 10 to the power minus 6 minus of 6 into 10 to the power minus 8. This value will give you 1.8 into 10 to the power minus 6 ohm inverse centimeter inverse. Now, what is the conductance, equivalent conductance of AgCl now? Equivalent conductance of AgCl will be specific conductance into 1000 by concentration. That concentration is also represented to be solubility. Solubility means concentration of the ions. So S will be equal to specific conductance by 1000 divided by equivalent conductance of silver chloride. So that will be equal to 1 point, specific conductance we found out here, K. 1.8 into 10 to the power minus 6 into 1000 divided by what is the equivalent conductance of silver chloride. They've given you the equivalent conductance at infinite dilution as 137.2. On simplification, we will get 1.31 into 10 to the power minus 5 molar. Solubility otherwise refers to the concentration of a particular ion in the solution. That's called a solubility. Maybe you would have heard of something called as solubility products. We have learned solubility products. So the answer for this is 1.31 into 10 to the power minus 5. Is it okay? Followed?
Yes, sir.
Yes, sir.
Yeah, the next question. The metal oxide which decompose on heating. The metal oxide which decompose on heating. I don't know whether it's been taught, Ellingham's diagram been taught to you in the college. General properties of metals. There's a chapter called as General Properties of Metals. There we would have taught to, our teachers would have taught to Ellingham's diagram. So forget about this. Now remember the Ellingham, it's the name of a person, Ellingham's diagram. So we will learn it later stages sometime. Now the mercuric oxide, when you heat, it will decompose to form mercury and gives you what? Oxygen. Just on heating. All the other three will not decompose. All the other three will require a reducing agent. But here the reducing agent is not required. Only on heating it will get reduced. This is called as thermal decomposition. Thermal decompositions mean decomposition only on heating is called as thermal decomposition. Not only silver oxide, mercuric oxide, silver oxide also will decompose. Silver oxide also just decomposes on heating to form silver, giving you oxygen. Both are examples for thermal decomposition. So all the other metal oxides require reducing agents. Only silver oxide will not require reducing agent. Therefore, the answer for this question is option B. The next question, Cu2 plus 1 molar, Zn2 plus 1 molar Zn Sl representative should have EMF. What's the EMF? This EMF should have the EMF. Can you identify what is this represented? Can you identify what is this? What is this cell called as? What is this
Daniel
cell?
cell, sir.
Daniel cell. What's the potential of Daniel cell? What's the potential of Daniel cell? 1.1 volt.
So 1.1.
Here you see, this is the reverse of Daniel cell, no?
Yes,
Here
sir.
Yes, sir.
So when the Daniel cell is reversed, what happens? The cell potential also has to be what? Reversed. So it should be what?
Negative.
But this is not going to happen. This reaction will not take place because copper should be cathode and zinc should be anode. But as per the question, what is the expected potential they're asking? So you should be what? Negative. Because for this, the potential is positive. For reverse reaction, expected potential is Negative. All right. So they're asking should have. It is not having. So what is that? It should have. What should be the value they're asking? It should be what? Negative. All right. The next question. When an electric current is passed through acidulated water, acidic water, acid containing water, 112 milliliter of hydrogen gas at NTP collects at cathode in 965 seconds. The current passed in amperes is W is equal to Z into I into T. See, since we are talking about hydrogen, the electrochemical equivalent will be what? Firstly, before that, 11,200 centimeter cube or ml of hydrogen gas will weigh 1 gram, 1.008 grams of hydrogen. Now, therefore, I can say 112 ml of hydrogen gas will weigh how much? It's 112 into 1 divided by 11200. Therefore, it will be what will be the value? I think 0.01 grams. 0.01 gram only, no. This is 0.01 gram. That will be equal to, what is Z? Z is 1 by 96,500. We don't know I. We have to calculate I. At the time they've given us 96,965. Calculate for I. I will be what? I will be what? What will be I? Okay. If I take this, multiply it by 0.01, what will I get? 965 is equal to I into 965. So I becomes what? I is what? 1 ampere.
1, sir.
Yeah, 1 ampere. Yeah, correct. So it will be what? 1 ampere. Right?
Yes, sir.
Yeah, this is again an arrow mark here, typing. Now, E naught for the reaction Fe plus Zn2 plus, giving you Zn plus Fe2 plus is minus 0.35 volt. The given cell reaction is feasible, not feasible, in equilibrium, can't say anything. What's the answer for this? What is the answer for this? We learned this question, similar questions here. Where is that? When E naught is positive, what happens? The reaction occurs, I told you. Reaction is feasible. But in this question, what they've given? They've given E naught to be what? Negative. E naught to be negative, minus 0.35 volt. So what will be delta G naught? Delta G naught is equal to minus NF E naught. So it'll be minus NF minus 0.35. So it'll be what? 0.35 NF. It becomes a positive value. When I say it becomes a positive value, it is what? Non-spontaneous. It means reaction is not possible. So therefore, the answer for this question is option B, not feasible. Followed?
Yes, sir.
Which of the following solution of KCl has lowest value of equivalent conductance? Which of the following solutions of KCl has the lowest conductance, lowest value for equivalent conductance? What is that equivalent conductance? What's the formula? Lambda is equal to specific conductance into 1000 divided by normality or concentration. Higher the concentration, conductance will be what? Low. Because concentration is in the denominator. Higher the concentration, what happens? The conductance becomes what? Less. Hence, the answer for this question is option 1.
Option
Yes or no?
Yes,
Are you able to understand? Equivalent conductance is inversely proportional to what? Concentration. Can you see that?
Yes, sir.
yes, sir.
So as the normality is more, the conductance will be what? Less.
Let's.
Yeah. The next question. Which of the following solutions of NaCl will have highest specific conductance? Specific conductance. There is no formula here. Specific conductance depends on what? Concentration. So specific conductance depends on the conductance of the solution in which the distance is what? 1 centimeter and area is what? 1 centimeter square. As the concentration is more, what happens? Conductance will be what? More. So therefore, the answer for this question is option D.
So
One
D.
now. Yeah. Now the next question. The molar conductance at infinite dilution of silver nitrate, it is AgNO3, man. See, I typed after coming from college. AgNO3, AgCl and NaCl is 116.5, 121.6, and 110.3, respectively. The molar conductance of silver nitrate. This is based on Kohlrausch's law. Molar conductance of silver nitrate will be what? Sodium nitrate. So it will be molar conductance of sodium chloride plus molar conductance of silver nitrate minus molar conductance of silver chloride. See what happens now. This minus Cl and this plus Cl gets cancelled. This minus Ag and this plus Ag gets cancelled. What we have? Sodium nitrate. So NaCl, what is the conductance they've given? Is 110.3, last one. And plus silver nitrate, they've given first one. It is 116.5 minus of 121.6. So on simplification, the answer what we will get is 105.2. So this is the molar conductance of sodium nitrate. Did you follow this? Yeah. Students,
Yes,
did you
sir.
follow? Yes. Maximum number of and different types of questions we have solved. It is if possible, you can solve some other questions and get back to me sometime later. So from this point of view, the electrochemistry we are done with. Next class, we will start with chemical kinetics. All right. All right.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yeah. Okay, ma'am.
Yes, sir.
Yeah,
Thank
ma'am,
you,
I'll
sir.
stop the class. Yeah, ma'am. Bye.
Thank you, sir. Bye, sir.
Bye. Bye. Bye.
Thank you,
Bye.